In this example, a production line is supposed to produce boxes of cereal that have an average of 20 ounces of cereal in the boxes. The line supervisor wants to know if the boxes are coming out with an average of 20 ounces per box like they're supposed to. So the hypotheses that were given are as follows. The null hypothesis is that the average amount of cereal in the boxes is 20 ounces of cereal. That's the mean equals 20. The alternative hypothesis is that the population mean is not equal to 20. That would mean that the boxes of cereal are coming out of the production line with something more than 20 ounces on average or something less than 20 ounces on average. So they're overfilled or they're underfilled on average. The supervisor collects a random sample of boxes from the production line and uses the sample statistic to find a p-value of 0.24. We're first asked to write a sentence to interpret the meaning of the p-value in context. Remember, when you're asked to interpret the meaning of a p-value in context, you should always start with the definition of p-value, which is as follows. If the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is the p-value. That's the definition. We then replace phrases and values within this definition to match the context and values given in this scenario. So, for example, this statement, if the null hypothesis is true, I will be replacing that with the actual null hypothesis in context. The null hypothesis was that the boxes have a mean of 20 ounces of cereal. So we are going to assume that that is actually true. So it would start with, if it is true that the boxes have an average, a mean of 20 ounces of cereal per box. Now we go to the second part of this. Then the probability of getting a sample statistic like ours or more extreme is the p-value. Well, we have been given the p-value, so we can actually replace this word p-value with the value given to us for the p-value. So the second part of our phrase would read, then the probability of getting a sample statistic like ours or more extreme is 24%. The p-value is 0.24, which is 24%. So overall, it reads, if it's true that the boxes of cereal have a mean of 20 ounces of cereal per box, then the probability of getting a sample statistic like ours or more extreme is 24%. That's a pretty good chance. There's a 24% chance of getting a sample statistic like we saw. So, Part B then says, which hypothesis should be supported if we're using a significance level of alpha equals 0.05? This means we're trying to draw an overall conclusion. Are we going to support the null hypothesis and say that the null hypothesis is plausible, or are we going to say that we support the alternative hypothesis? Remember, to make that decision, you need to compare your p-value to the significance level alpha. In this case, our p-value is equal to 0.24, and our alpha is equal to 0.05. Our p-value is bigger than our significance level alpha. When the p-value is bigger, that means that we're going to say that the null hypothesis is plausible. So since the p-value is bigger than the significance level, we conclude the null hypothesis is plausible. So our conclusion is it is plausible that the boxes have a mean of 20 ounces of cereal per box.